Today, we are going to discuss the different types of APIs. APIs, or application programming interfaces, come in a variety of flavors. Over the years, as technology and requirements evolved, so did the methods and standards for communicating between different software entities. Let's explore these different types of APIs, their features, and real-world usage. REST is the most widely used today. Let's explore its background and history. In terms of its origin, REST was conceptualized by Dr. Roy Fielding in his 2000 doctoral dissertation. It emerged as a response to the complexities of SOAP and other similar web architectures. In terms of the philosophy, REST isn't a protocol or a standard, it's an architectural style or guidelines. The essence of REST is to treat everything as a resource which can be operated upon using standard HTTP methods. Here are some of the characteristics of REST. Statelessness. Every request from a client or a server must contain all the information needed to be understood. The server shouldn't store any context between requests. Client-server architecture. The client is responsible for the user interface and user experience, and the server is responsible for storing and retrieving the data. This separation allows for scalability and flexibility. Cacheability. Responses from the server can be cached by the client to improve performance. Layered system. Each layer of an architecture can't be seen beyond the immediate layer which it interacts. This ensures that changes in one layer do not affect changes in others, promoting modularity and flexibility. Code on demand. It's optional, but it allows the server to extend a client's functionality by sending executable code. In terms of the data formats, it uses JSON, which is a lightweight data interchange format that's easy to read and write for humans to easily parse for machines. Due to its simplicity and efficiency, it has become the standard for many REST APIs. XML is a markable language that defines rules for encoding documents. It's more verbose than JSON, but still widely used, especially in legacy systems. HTTP methods in REST. Get, retrieve a specific resource for a collection of resources. Post, create a new resource. Put, update an existing resource. Delete, remove a resource. And patch, apply partial modifications to a resource. Here are some of the best practices for REST. Stateless interactions include or ensure that no client context is stored between the server request. Use HTTP status codes. Use standard codes to indicate the outcome of an API request. For example, 200 for success, 404 for not found, 500 for server errors. Versioning. Implement versioning to ensure backward compatibility when the API evolves. Error handling. Provide meaningful error messages to aid the debugging and issue resolution. And security. Implement standard security protocols like OAuth for authentication and authorization. Now let's talk about SOAP. In terms of its background and history, SOAP was developed as a protocol in the late 1990s for programs running on different operating systems, such as Windows and Linux, to communicate with each other. This was a major evolution in bridging the cross-platform communication gap. Standardization. Adopted by the World Wide Web Consortium and became a widely used standard for web service communication. Industries. It was predominantly favored by financial services, enterprise integrations, and other sectors needing a high level of security and ACID compliance. Characteristics. Although most commonly used with HTTP and HTTPS, SOAP can function over any protocol such as SMTP or even TCP. Language neutrality can be implemented by any program language, giving it a versatile edge. Structured information. SOAP uses XML to format its messages, which is both readable and a widely accepted standard. Here is the structure of SOAP. It has an envelope, which has the root element which defines the start and the end of message and encapsulates all those details. It also has a header. The header contains metadata for the message. It includes authentication, transactions, payment processing, etc. Headers are optional, but they do offer capability extensions. Body. This is where the actual message content resides. The body carries the details of the request and the response. Fault. An optional sub-element of the body, it provides information about errors which occurred while processing the message. Web service standards. Web service security adds security to the web service, ensuring data integrity and confidentiality. It also supports multiple security tokens. Readable messaging. This helps to deliver messages reliably between distributed applications. It's crucial in applications like financial transactions. Atomic transaction manages transaction to ensure ACID properties. This is vital in use cases which transfer the autonomy is necessary. Discovery provides a way to discover services running on a network. Here are some advantages and disadvantages of SOAP. Advantages. It's highly extensible via the WS standards. Strong typing using XML schema. Provides a mechanism for service discovery using UDDI. Built-in error handling with the fault element. Strict standards help to ensure uniformity. Here are a few disadvantages. It can be bulky due to verbose XML format. Parsing XML can be CPU and memory intensive, and it also tends to be slower and requires more bandwidth compared to other lightweight protocols. Let's look at GraphQL. GraphQL was developed by Facebook in 2012 and released as an open source project in 2015. It was developed to solve some of the inefficiencies associated with traditional REST APIs. In terms of the philosophy, GraphQL stands out with its flexibility query language, enabling clients to request exactly what they need and nothing more. This reduces the amount of overfetching or underfetching of the data. In terms of GraphQL characteristics, it has strongly typed. Every GraphQL schema is associated with a set of types, and every query is validated against the schema. Single endpoint. Unlike REST, which uses multiple endpoints for different resources, GraphQL typically exposes a single endpoint for all interactions. Descriptive. The schema and type system ensure that GraphQL is self-documenting, and it can introspect the schema the capabilities of the API instantly. The structure of GraphQL. Queries. For reading and fetching of data, it's analogous to the GET request in REST. Mutations. For writing and modifying data. This can encompass creating, updating, or deleting data. Subscriptions. To maintain real-time connection with the server and get instant updates when data changes. Here are some advantages and disadvantages of GraphQL. Advantages. Flexibility. Clients can get exactly what they want in a single request. Strongly typed. ensure data integrity, and reduces runtime bugs. Introspective. Clients can discover capabilities through schema introspection. Disadvantages. Learning curve. For teams used to using REST, there might be an initial learning curve. And complex queries. If not monitored, clients can potentially ask for a lot of nested data, resulting in performance issues. RPC. Let's look at its background and its history. The concept of RPC dates back to the early days of distributed computing. It was designed to allow programs to call a procedure to execute in another address space. Philosophy. At its core, RPC is about executing a procedure or a method on a remote server rather than the local computer. Characteristics. Synchronous nature. Traditional RPCs are often blocking, meaning that the client sends a request to the server and becomes blocked, waiting until the server has processed the request and sent back the response. Stub. In RPC systems, the client and server code are often generated from a common interface, with the client processing the stub that provides the interface to the actual remote methods. Transparency. RPC mechanisms strive to make the communication better between the client and the server transparent to the programmer. Let's look at some common implementations of RPC. XML RPC is a simple, portable way to make remote procedure calls over HTTP. It can be used with a wide variety of programming languages. JSON RPC. Much like XML RPC, but instead of XML, requests are encoded in JSON. gRPC. Developed by Google, it's a modern open source RPC framework that can run in any environment. It uses protocol buffers as its interface definition languages. Here are some advantages and disadvantages. Advantages. Efficiency. Especially with binary protocols, RPC can be much more efficient compared to textual protocols like REST. Strong typing. Uses systems like protocol buffers with gRPC offers strong typing. Streaming. Protocols like gRPC support bidirectional streaming. Disadvantages. Complexity. More complexity compared to REST in certain implementations. Less web-friendly. Traditional RPCs may not be as web-friendly or easy to debug as your HTTP approaches. Webhooks. In terms of the background and history, as the web applications grew more complex and interactive, there emerged a need for real-time data updates without constantly polling a server. This led to the development of webhooks as a push mechanism. Philosophy. Webhooks are essentially user-defined HTTP callbacks. They provide a way for apps to communicate automatically with each other by sending real-time data whenever a specified event occurred. Characteristics. Event-driven. Webhooks operate on the principle of events. When a specific event occurs in the source application, it triggers the webhook to send data to the target URL. Asynchronous. Webhooks work asynchronously, meaning that the source application doesn't wait for the receiving application to respond. Simplicity. As its core, a webhook is just an HTTP request that goes to a specific URL. Common use cases of webhooks include notifications. Notification to admin when a user signs into a platform. Continuous integration and continuous deployment. Triggering builds or deployments based on code commits. Data integration. Automatically updating CRM records when a user modifies their profile in a web application. Here are some advantages and disadvantages of webhooks. Advantages: real-time operation. Instantly sends data without waiting for periodic checks. Reduced server load. Eliminates the need for constant polling, thus saving resources. Flexibility. Can be integrated with almost any application, offering extensibility and interoperability. Disadvantages: security concerns. If not properly secured, webhooks can be exploited. Unreliable networks. Since they're asynchronous, there's no guarantee of data delivery, especially on unstable networks. As we have reviewed in this chapter, there are many types of APIs. REST are the most widely used today. Each API serves its own purpose and advantages and disadvantages to using them.